In this video, we're going to learn about the rectangle. So by definition, a rectangle is a parallelogram with four right angles. So since it is a parallelogram, that means it inherits all of those parallelogram properties. So opposite sides congruent, opposite sides parallel, diagonals bisect each other, and all of the other additional parallelogram properties are true for a rectangle. Also, if you think about where a rectangle is located on the flow chart, it's below an isosceles trapezoid and a parallelogram, so really it's inheriting both sets of properties. So then looking at some new properties for a rectangle, in addition to all of the parallelogram and isosceles trapezoid properties, it also has congruent diagonals and all angles are right angles. So all angles are right angles, that's the definition of a rectangle. That's what makes it different than a parallelogram. But then also having the congruent diagonals, it's inheriting that from that isosceles trapezoid. So what that means in this picture, these two diagonals are congruent to each other. So let's just put some letters on here, A, B, C, D. So that means diagonal AC is congruent to diagonal DB, which because the rectangle is a parallelogram, that means that the diagonals are bisecting each other. And since they're congruent, that really means that all four parts here are congruent in a rectangle. So that's important to make note of. And then the other thing is we have four right angles. So these are our four right angles. So when you think rectangle, you probably think four right angles, or a quadrilateral that has four right angles. So looking at some examples of how we use these properties, in this first picture we have a rectangle ABCD. So let's go ahead and sketch that. Make sure when you label it, you're going around the figure. So A, B, C, D. It says that AB is 15. BC is 6, we want to find the length of the diagonal. So the easiest way is, since we know that the diagonals are congruent, it doesn't matter if you find the length of AC or DB. But I'm going to go ahead and say let's find the length of AC, because then hopefully what you're seeing here is you have a right triangle. So then really, because remember we have four right angles, so then really what this becomes is a Pythagorean theorem problem. So I can go ahead and plug into Pythagorean theorem. Now, keep in mind, I could have also said, well, since it's a rectangle, opposite sides are congruent. So this is 6, this would be 15. And then I could have used those two sides in this diagonal again, or I could have found diagonal BD using these two sides. It doesn't really matter. There's lots of ways to figure out this problem. So let's go ahead and plug in. So I have 15 squared plus 6 squared equals x squared. So I'm going to get these 15 squared. I'm going to go ahead and just combine those. So 15 squared is 225 plus 36. So I end up with 261 equals x squared. And then I'm going to square root both sides. So I'm just going to rewrite that up here. So x is going to be equal to the square root of 261. And then this says to simplify into simplest radical form. So let's go ahead and try some different perfect squares and see if they're factors of 261 and go from there. So right away I'm trying 9, and when I divide 261 by 9 I'm getting 29, so that's going to be the way to go here. So I have square root of 9 and square root of 29, so this will reduce down to 3 root 29. So that means the diagonal is equal to 3 root square root of 29. So there's the first thing. So then we look at the second example here. It says in rectangle ABCD we have diagonals AC and BD. So let's go ahead again. Always sketching a picture here is going to be important. So we have ABCD going around the rectangle. We have diagonals BD and AC that are intersecting at this point E. Then it says that AE is 10x plus 20. So AE is 10x plus 20. And CE is negative 4x plus 76. We want to find the value of BD, or the length of BD. So the first thing I need to do is solve for x. And if I know x, that will allow me to find AC. And since in a rectangle, the diagonals are equal, well, if I know AC, I'll know the length of BD. So that's kind of where I'm going to go, because remember, all four of these parts are equal because the diagonals bisect each other since it's a parallelogram, and the diagonals are congruent because it's a rectangle, so all four parts are congruent. So what I'm going to do is I'm going to set those two parts equal. So start with that. And then I'm going to solve for x. So solving for x, let's bring the 4x over. And then subtract off the 20 from both sides. So we end up with 14x equals 56. Divide 56 by 14, and we end up with 4 for x. So then what I need to do is I need to find BD, which is equal to AC, which is equal to those parts added together. So I'm going to just show that I'm plugging in. So there's the first part plus -4 times 4 plus 76. And then I'm just going to enter all of that into my calculator. I end up with 120 for that. So BD is equal to 120. So again, more algebraic type examples just using the properties. So the last algebraic question here, well, this isn't actually an algebraic question, but the last thing we're going to look at is looking at coordinate proofs. So in order to look at coordinate proofs, this example here saying is, if a quadrilateral is a parallelogram with one right angle, is this enough to prove it's a rectangle? So let's think about that. If we have a parallelogram, so opposite sides congruent, opposite sides parallel, so with one right angle, so let's say here's my one right angle, and these are my two sides of my parallelogram. Well, in a parallelogram, opposite sides are congruent, so that means this side has to be the same as what's over here. This side has to be the same as what's down here. Also, keep in mind your opposite angles are congruent, so that would make this a right angle. And consecutive angles are supplementary in a parallelogram, so if this is 90, this has to be 90. And if this is 90, well, this one's also 90. So any way you look at it, you're going to have, if you have a parallelogram with one right angle, that's going to be enough to prove it is a rectangle. And you could think of it many different ways. The fact that opposite sides have to be congruent, or because the opposite sides are parallel, that makes those same side interior angles, which are supplementary. Lots of different options. So I'm going to say yes. And I'm going to use the fact that opposite angles, I'm going to go with that approach. I think it's a little bit easier to explain. Yes, because opposite angles are congruent and consecutive angles are supplementary in a parallelogram. So meaning if you have one right angle, well, then the opposite angles has to be a right angle, and then the two consecutive angles also have to be right angles in order to add to 180. So that's kind of, I think, the easiest way to explain why it works. So that brings us to this last question, which is how can we prove that we have a rectangle? So there's three different approaches here. One is just the definition of a rectangle. Okay, it's a quadrilateral that has four right angles, or it's a parallelogram with four right angles. So you can show, this is probably the most common way, is just to show, well, what makes a rectangle different than the other quadrilaterals? Well, it has four right angles. So that's this most probably common way of doing that. So that would mean showing that you have negative reciprocal slopes forming by the adjacent sides, so that you have perpendicular lines which form right angles. The other two approaches are both of these. You could show you have a parallelogram with one right angle, which we just talked about, or you could show it's a parallelogram with congruent diagonals. Because then basically what you're doing is, if you think about your flow chart, you're taking your parallelogram, you're merging it with an isosceles trapezoid, which is therefore forming a rectangle. So I'm going to use this first approach just because, like I said, it's the most common. So I'm going to go ahead and I'm going to plot my points here. So I have P, I have 1, 2, 3, 4, up 8, 2, 4, 6, 8. R is 7, 6, so 2, 4, 6, 7, 2, 4, 6. Remember, this should look like a rectangle, so if you're plotting something that's not looking like a rectangle and it's asking you to prove a rectangle, means check your plotting. So I'm going to use this first approach. I'm going to show I have 4 right angles, so that means I need to show the slopes of all 4 sides. I need to make sure that the adjacent sides are negative reciprocal slopes. So basically pick whatever letters you want. Let's say let me write my slope formula. So it's the change in y's over the change in x's. And I'm going to make sure that I'm labeling these as I go. So I'm just going to start with PQ. So the change in y's, so subtracting the y values, subtracting the x values. So this is going to give me 6 over 4, which reduces down to 3/2. I'm going to move on to the next side adjacent to that. So I'm going to say the slope of QR. So the slope of QR, I'm going to subtract, so 6 minus 8, and then 7 minus 4. So this is going to give me negative 2 over 3. So this is good because right now I'm seeing that these are negative reciprocals. So therefore I know that angle Q is a right angle. I continue the process here. I'm going to work on the slope of RS. So RS, I have 0 minus 6 on top, and then 3 minus 7 on the bottom. So this is going to be negative 6 over negative 4, which will reduce down to 3/2. So again, comparing this with this, because those are the 2 adjacent sides, those have negative reciprocal slopes. And now the last side I have to find is PS. So the slope of PS is going to be 0 minus 2 over 3 minus 0, so negative 2 over 3, which again is good because this slope, PS, is perpendicular to RS, so it's perpendicular to this, and it's also, PS is also perpendicular to PQ because those are flipped and negated. So that means both of these are right angles. So therefore, this quadrilateral must be a rectangle. So my conclusion here, I can say quad PQRS is a rectangle because the slopes of all adjacent or consecutive, if you'd rather say that, of all adjacent sides are negative reciprocals making 4 right angles. So therefore my work verifies that first method up top there, which shows that this is a rectangle because I've shown that I have 4 right angles in this quadrilateral. So that's one approach, not the only approach, but one that's most common. So go ahead and check your understanding problems, and we will do more with rectangle coordinate proofs tomorrow when you come into class.